Right. So, this is a systematization of knowledge paper. So, glorified survey paper with some insight, trying to present Bitcoin in a more sensible way. Really, this is the result of over 3 years of research and looking into Bitcoin with this beautiful group of people here. It's been multiple institutions, multiple papers, and we thought it would be great if we could capture everything that we learned over the years in this survey paper. So, one of the goals was just to have a nice all-in-one place where you can read about Bitcoin. A big problem facing people who want to learn more about Bitcoin is that the information is really fragmented. There's an original white paper. Unfortunately, that's kind of stale. The system as implemented is quite different than the white paper in some places. So a lot of how Bitcoin works is split among forum postings and the actual source code. We spent a lot of time wading through that on mailing lists on IRC. Hopefully, to make it easier to get into Bitcoin, we have a nice white paper with academic terminology and tables with circles and half-filled in circles like you expect in any good SoK. But more exciting, and what I'll be talking about today, is some of the open research challenges that we highlighted in the paper. So with that, I should warn that this unfortunately won't be a completely self-contained talk. 16 minutes is really not enough time to explain all of how Bitcoin works. We have also, as a result of this, put together an online course. We're writing a textbook. So, Bitcoin is a fairly deep topic. It takes a while to get up to speed. So for the purposes of this talk, I'm just going to dive in into the exciting open research and hope that everybody has some passing familiarity with Bitcoin. So one of the things that we found when, in the course of years of dialogue with the Bitcoin community, developers and people running Bitcoin businesses, sometimes there's a little bit of a difference in language and culture between academia and the Bitcoin community. So sometimes you'll sort of hear from people working on Bitcoin, portrayed by this code monkey here, that they're not too interested in what academics have to say. They sort of feel like this was, invented outside of academia and grew to be a working system with almost no attention or insight. So they're, sometimes they can be wary of academics trampling in and saying, now I'm gonna tell you how to make this system better that really, was developed outside of the academic literature. And from the Bitcoin community's perspective, sometimes they see academics represented by this professor dog here, kind of wandering in and saying, oh, Bitcoin is a bunch of old stuff. We really developed these ideas a long time ago. We knew how to do cryptocurrency and Byzantine consensus. So there's nothing exciting, nothing new for us to do here, and this isn't really worthy of our time. So obviously I'm going to tell you I think that both of these perspectives are wrong, and it would be nice if we had better dialogue where academics respect that there's really a lot of cool new stuff in Bitcoin, and the developer community realizes that academia has a lot to contribute. There's a lot of open problems that more academic theory could really help with. So why should we care about Bitcoin at all? It's certainly impacting the world. I think that point is indisputable now. There's over $3 billion of value just in Bitcoin alone, not to mention all the other cryptocurrencies. It is being used by real things. It's not just being used for criminal transactions. Don't be thrown by the fact that the 3 Bitcoin talks were thrown into the cybercrime session at Oakland. It is a real thing. There's a real economy. So your Bitcoin research can really impact quite a lot of people. And if that's not enough to move you, if you're not one to care about practical impact, it's fascinating on its own sake from a research perspective. There's really cool open questions, and it's really advanced our understanding of what's possible with security and with crypto. The other thing that we hear sometimes from other academics is Bitcoin a fad? Is it sort of a waste of time for us to be researching this thing that might tank, might go away? So I certainly don't want to argue that we know for some certainty that Bitcoin will be around forever, that it will really exist in 2140 when the last Bitcoin is scheduled to be mined. But I'd argue that even if Bitcoin itself, and there's a lot of ways that Bitcoin could die, but even if Bitcoin itself dies, the analogy is kind of like the Apollo 1 or early spacecraft, where if we look at them now, they look sort of outdated. We're not launching spacecraft that look exactly like this anymore. But it led to a change of thinking. And even if that original spacecraft is not around anymore, a whole bunch of new, really exciting stuff came out of that, including famously Tang. So I think that even if Bitcoin itself doesn't prove to be the ultimate cryptocurrency that the entire world switches all finance over to, the post-Bitcoin era, if it exists, is going to be very different from the pre-Bitcoin era. I think it's very unlikely that we just decide that cryptocurrency was a bad idea and that we're not going to do it. It's almost certain now that cryptocurrency will be with us, and a lot of the ideas that we're developing researching Bitcoin are going to influence that forever. Okay, so diving into what we actually talk about in the paper. The way we present Bitcoin, which I think is most helpful if you're coming at it for the first time, and I haven't seen this breakdown presented very often, but I think it's helpful, is to think of three main protocols in Bitcoin. So it's really three main protocols in one, plus sort of a human level protocol on top of it. So starting from the bottom up, there's a consensus protocol, which is probably the most widely discussed. This is the blockchain and the mining. This is how a group of people form decentralized consensus on some string of bits, which is the Bitcoin blockchain. But sitting on top of that, for it to be actually useful, there's this transactions protocol by which we agree that the bits that are agreed to in that blockchain actually represent accounts and transfers between people and money and value. So that's where the scripts and all of the notions of smart contracts and a lot of that functionality of Bitcoin lives. And then probably the more ignored protocol of Bitcoin is the network protocol. There's a peer-to-peer network. This is how everybody shares the transactions and learns about blocks and new information within the system. So it's not a perfect decomposition. These layers depend on each other a little bit. The consensus layer depends on the transaction layer because the miners have to validate transactions. It also depends on the network layer because the miners have to talk over the network. But at a high level, you can split Bitcoin up into three protocols this way. And doing that, I think I can argue that the innovation is mostly at the bottom of Bitcoin. So at the top, at the network layer, even though it's a large deployment, and I think we've learned a lot about peer-to-peer networks in practice from observing Bitcoin, the ideas here had appeared before in different places. So the peer-to-peer literature is like 15 years old, and a lot of ideas from it are recycled pretty directly in Bitcoin. The transactions layer of Bitcoin, the ideas had sort of existed in various forms pre-Bitcoin, but it's really the first practical implementation of them. So we've seen sort of smart contracts and transactions and a transaction graph, how to do analysis on that for the first time in practice with Bitcoin. And at the bottom, the consensus layer is really a strong, sharp break from all of the previous academic literature on how to do distributed consensus. And I think it's worth asking, why did this big break? If you think the core innovation of Bitcoin is the consensus protocol there, why did it take until 2008? Because none of the technology, it's really just hash functions and simple cryptography. Why did it take until 2008? So I don't have the answer here, but I'll throw out the basic theories. One is just that the idea of having everybody store everything forever was considered implausible for a long time. And as the price of storage went down, this started to seem more reasonable until the mid-2000s when it really started to make sense. And now everybody has a laptop that's capable of storing the entire Bitcoin blockchain. The other argument is really just that it's a non-obvious solution, that from the academic perspective, cryptocurrency and Byzantine consensus were two distinct research topics, and nobody had thought about what if we tie the two together. The problem was sort of solved in the academic literature, but under very different assumptions. Okay, so I'll talk about some of the key research challenges. I'll again use that three-layer breakdown. And starting with the network layer, there's a lot of interesting papers both on the measurement side, how well is the Bitcoin network working, what are some tweaks we can make that might make it work better, and on the attack side, how can we mess with the network and how can we try and confuse people. one of the big research questions in practice is what would happen if one parameter in Bitcoin, the maximum size of a block, was changed. So it may sound like a very small point, but the Bitcoin community has basically been debating this for 2 years and are very nervous about making this change. And if we had a good theoretical understanding of how this network worked, we might have a better understanding that this is a safe change to make and that we could actually make the Bitcoin network handle a lot more transactions. And later on in this session, we'll see a perfect example of a great paper looking at a novel attack on the network layer in Bitcoin. At the transaction layer, most of the research is around enabling new kinds of functionality, either better privacy, new applications, new things we want to build on top of Bitcoin. And it comes at 2 levels. It's either altcoins or alternative currencies, where people want to create a new system with more rules in Bitcoin to allow more functionality. And there's also just a lot of cleverness in squeezing more interesting functionality out of what's already there in Bitcoin. And the evolution, the kind of the endpoint for that research is, can we have a cryptocurrency that actually has Turing-complete scripts? So any contract that we could write a program for is actually enforceable by the cryptocurrency. Completely open question. At the consensus layer, the research questions are in some sense more basic. In one sentence, the question is basically, does this work at all? It obviously works fairly well in practice, or at least it's worked in practice so far. But we'd like to have some theoretical understanding that this will remain stable in the long term, that the Bitcoin consensus algorithm will really continue to provide the properties that we want it to provide for Bitcoin to function as a currency. Again, we'll have another talk right after this one about the consensus layer and how mining pools work and how that might affect stability of Bitcoin's consensus protocol. But I'll dig in a little bit to give you, one moment of depth in this talk and try and talk about why this stability question for Bitcoin is a hard research challenge. So like I said, the goal is really to just say, what properties do we actually need this consensus algorithm to exhibit? What conditions are necessary for those properties to hold? And then, in the real world, when are those conditions actually going to be true? So if we could hit all 3 of these points, then we could argue, yes, Bitcoin will still, the system will still function long into the future. So there've been, there's no universal agreement on exactly what properties we need the consensus algorithm to satisfy. In the paper, we tried to synthesize a few different papers into 5 general properties here. But these are definitely not unambiguous. In particular, this correctness property, even though it sounds like correctness should be an absolute must-have, it turns out it's not a must-have for Bitcoin. You could have a cryptocurrency that doesn't have correctness. And I should qualify that and say correctness just means that anything that gets included in the blockchain is actually a valid transaction. It's actually fine if you drop that property. It's just a big efficiency hit. So it's normally included as a property that we really want to have. So the question really becomes, what assumptions do we need to make to prove that those properties hold? If you make some quite strong assumptions, then you can prove that they hold. So just for example, we have to assume the majority of miners are running the default protocol, not making any changes. The only thing that attackers care about is making a Bitcoin profit. They don't care about the actual real-world value of those Bitcoins. And we have to assume that that network layer basically works perfectly. And if you make all those assumptions, you can prove that 4 of the 5 properties I showed you hold. But it's actually not enough to ensure fairness. Fairness meaning that all of the miners who are participating in the protocol get rewarded equally to how much effort they actually put in. So if you want to prove fairness, you have to add an even stronger assumption, which is beyond even having a perfect network, but complete perfect information, so nobody has any private state at all. So these are quite strong. I think I don't need to spend too long convincing you that these assumptions don't hold true in practice. But that's the challenge, is how much can we weaken these assumptions and still say something interesting about Bitcoin's consensus algorithm providing some useful properties. Okay, so with my remaining few minutes, I'll do the slide where I throw a lot of stuff on one slide that you can't possibly read to try to argue that there's really a lot in the paper for you to go and read. But I'll just step through really quickly and wave my hands and say, all of the things that people would like to change about Bitcoin, making mining more egalitarian, maybe doing something useful with that mining, doing the mining in such a way that it doesn't burn any electricity. Maybe get rid of the mining completely. So those are just ideas that people are working hard on to try and make the consensus layer better. And then at the transaction layer, this is where everybody's dreaming about how much cool new stuff can we build? Can we have really strong absolute guarantees of privacy? Can we build cool new functionality like distributed PKI or DNS? Really smart contracts and property. And like I said, Turing completeness. Can we take this all the way to the limit so that we can do anything we can imagine in the cryptocurrency? So it kind of boils down to, for any future system, what could we or should we design differently from the original proposal? And either the cool thing or the sad thing, depending on how you look at it, is that we really don't have any notion of what we would change from the original design. Sometimes in the Bitcoin community, there's just an assumption that the original protocol was just kind of nailed in one try by Satoshi. I think that's not quite right. And sometimes on the academic side, we say, well, we don't really have a strong theory saying any of this stuff really works. So we can't really make any design decision with too much confidence. So I'll leave you with, if I hadn't said it enough times, Bitcoin is a great research topic. So skip the rest of Oakland and just start researching Bitcoin now. It's that good. But seriously, I mean, your research will get out there. People have real hard problems that they're facing in practice. There's a lot of companies that want to implement your papers immediately, which is cool. And almost no matter what area of security research you're interested in, there's open problems. When I presented this research in Cambridge, my supervisor, Ross Anderson, he said that Bitcoin looks like a full employment act for security engineers, because we'll all be employed forever trying to do all the research that there is around Bitcoin. And finally, I'd say, given the opportunity, you should teach Bitcoin. I got to teach a course for undergrads and grad students at Princeton. I'll be doing the same at Stanford, and it's fantastic. The students love it. We told the students on day one, Bitcoin is really just a Trojan to get knowledge about crypto and other CS topics into your heads. They said that's not going to work, and it worked anyway. By the end of the class, we talked about everything from queuing theory to NP completeness, and it was awesome. So if anybody's interested in teaching Bitcoin, please come up to me, and I'd love to share some experience in teaching materials and stuff. And with that, I'll take a couple questions.
Thank you for the talk. Any questions?
Hi, I'm Ben Kreuter at Google. So it sounds like you're making progress towards a strong or a formalized definition of security for Bitcoin. Mm-hmm. So previous security definitions for like digital cash have been kind of strongly based on economic understandings of what money is, and Bitcoin kind of departs from those in a very significant way. Do you find that you guys are also working towards a sort of new definition of money as you do this, or are you focusing more on just the consensus aspects?
Yeah, it's a good question. I mean, I think maybe the broader point is that when you try and study consensus, if you really try and model the whole world and weaken those assumptions, you get into reasoning about exchange rates, and you get into some heavy economic theory pretty quickly. We tried to limit the scope a little bit in the paper and just say, there's sort of this magic that happens where people agree that this currency is valuable, and assuming that people do that, we can reason about the security. So yeah, I mean, the broader SoK paper would include, if we wanted to get economists and behavioral psychologists involved, there's a lot of great topics about Bitcoin too. Didn't look at that quite as much in this work.
Thank you.
Any other questions? I have a question, if no other questions. So maybe we can comment on the consensus protocol in Bitcoin. How is it different than the traditional Byzantine consensus discussed in the academic literature for many years? What made this design different than everything else proposed so far?
Sure. I mean, the high-level difference is that it's based on computational power to prevent against Sybil attacks. So there's no closed set of participants. The participant list is completely open and can change at any time. And you basically gain voting power in proportion to how much computational power you have. That's probably the biggest break in design setup from traditional Byzantine consensus.
Okay, more questions? Yes.
So it seems to me that Bitcoin is a way of encouraging people to steal energy, and it is, in a sense, immoral, in that it purports to produce value out of nothing. Usually, when you say there's some value, you can find some value somewhere, but in Bitcoin there is none at all. So how does it work?
So I think it's like I said at one point, one of the really interesting questions that a lot of people are working on and proposed designs in a couple different directions is, can you have Bitcoin-like consensus without mining, without burning any power? So a lot of people are working on that. They sort of seem to work, but we don't have the practical experience of them being as big as Bitcoin, so there might be attacks that we don't know about yet. But it seems like it is possible to do Bitcoin, to have a cryptocurrency with an open, decentralized consensus protocol without burning energy. And also there's the argument from the Bitcoin community that the total amount of energy that Bitcoin burns, which isn't known exactly, but it's somewhere in the low hundreds of megawatts. If you do a comparison to how much energy the banking system burns to mint coins and to drive currency around, there's some use of energy to achieve anything, including currency. So I guess I would challenge the notion that the energy is being wasted. If the 100 megawatts are being burned to enable a currency system that tens of millions of people are using, then the energy is actually being used for something.
Okay, unfortunately we don't have time for additional questions. Let's thank the speaker again.